Welcome to EDU World Space.
So now we'll work on problem 8 from chapter 20. In this question, we're asked to consider a voltaic cell, which we can reproduce here. So we have two beakers. We have two electrodes connected by a voltmeter. We have some solution in each, and we have a salt bridge. We're indicated the electrons are flowing this way. And let's go ahead and write in our species. We have iron and silver. So we have an iron electrode here, a silver electrode here, and then we have silver plus here and Fe iron 2 here. So the first question that we're asked is, which electrode is the cathode? The cathode is where reduction occurs. We also know that electrons flow from anode to cathode. So we see the direction of the electrons is going to the right from iron to the silver. So that means that silver is the cathode. So in part B of this problem, we're asked to calculate the standard EMF generated by the cell. So to do that, all we have to do is find these standard values and subtract the cathode from the anode. So the cathode for silver reduction is 0.80, and we subtract the iron reduction, which is 0.44. So our standard value here is 1.24 volts. In part C, they're asking us, what is the change in the cell voltage when the ion concentrations in the cathode half cell are increased by a factor of 10? So basically, we're increasing this 10 times. So to calculate this here, we need to use the Nernst equation. So the Nernst equation tells us that E is equal to E naught, the value we just calculated, 1.24, minus 0.0592. We also have, it's going to be divided by N, which in this case is 2. And then the log of Q, which is going to be 1 over 10 squared. And if we do this calculation here, we get 1.30 volts. And in part D, they're asking us, what about if we increase the concentration of ions in the anode by 10? So we do the same thing, is equal to 1.24 minus 0.0592. The only difference here will be the Q value. So we have a log, and then we have 10 over 1 squared, so they're reversed because we're talking about the anode now. And when we do this calculation, we get a value of 1.21